Today we are going to be designing an earthquake-proof tower. One important job that some engineers have is designing buildings that can stand up to natural disasters like earthquakes. Now, we live in Michigan, so there aren't a lot of earthquakes that happen here. So I don't know if any of you guys have experienced one, but what happens in an earthquake is the ground starts to move from side to side. So you can probably imagine if you're a building that's attached to the ground and the ground starts moving from side to side, that building is in danger of collapsing. So to show you how this works, I have a cube made out of spaghetti and marshmallows, which we're going to pretend is a building. Now, the first thing that happens when the ground starts to move from side to side is the building might start to tilt as the ground moves. And you can see this building, which is made out of cubes, is tilting quite a lot. The other thing that can happen is the ground might start to move up and down, which will make this start to bend in a little bit. And then the last thing that can happen is the building will start to twist like this. So this presents a challenge. How do you design a building that can stand up to moving ground without falling down? There are strategies engineers use to make the structure more stable. So I'm going to draw a quick picture of that spaghetti tower we were looking at earlier. It's going to have 2 floors this time. So here's my spaghettis and the little marshmallows that were connecting them. Now, if you remember, that tower was not stable at all. When I pushed the cubes, they just bent, right? So, to make this tower more stable, engineers will incorporate triangles, which are much more stable than squares are. So this might look like putting a brace here on all these corners, or maybe all the way across. Anything you can do that will create more triangular shapes in your structure will make that building stronger. And if you can imagine pushing this, or trying to push this building over, instead of the square just flipping over, these braces will block it from you being able to push it over as quickly, which will make your building stronger if an earthquake comes. To make your own earthquake-proof tower, you're going to need a few different materials. You'll need some pieces of dried spaghetti, marshmallows, a roll of tape, and a paper plate or a regular plate. Once you have all your materials, you can start building your tower. So I'm going to use the pieces of spaghetti as the main structure, and then you can use the marshmallows to connect them together. You can build your tower however you want, but we're going to simulate an earthquake after the tower is built. So try to make it, using what we just talked about, try to make it as earthquake-proof as possible. So I'm just building a base layer here. You do not have to build yours like I'm building mine. You can do it however you like. Now, if you want to add some braces, my spaghettis are not long enough to go all the way across. So you can break, depending on how big you want your brace to be. I might just put one in the corner here. So you can break your spaghetti in half and then just use a little bit of tape to secure it. Try not to use too much tape. If you're having trouble using tape to connect the braces of your structure, You could also try, if you have enough marshmallows, sliding a marshmallow down the spaghetti noodle. Oops. And then using that to connect your joints. If you're having trouble keeping your tower up while you're building it, you can also use a water bottle or another tall object to stabilize it while you're building it. Once you have your tower built, it's time to test if it's earthquake proof. So you're going to take the plate you have, and I'm going to flip mine upside down. And then very carefully you're going to transfer your tower onto the plate. And then using some tape, you're going to tape the tower onto the plate. Once your tower is secured to the plate, it's time to begin the shake test. So you're going to take the plate and start moving it side to side to simulate the earthquake. And then you can start going faster and faster and see if you can get your tower to fall down. If it doesn't fall down, you must have done a pretty good job earthquake proofing it. There are other ways you can test your tower besides using a plate. If you have Jell-O at your house, you can make a pan of Jell-O and then put your tower on the Jell-O and shake the Jell-O pan around, and that can simulate an earthquake too.